The memsys process. The memsys process is a revolutionary new thermal separation process working with distillation under vacuum and multiple recycling of energy. This animation will explain its basic functionality on the example of salt water desalination, but the memsys process could be used to separate many other solutions. The memsys process happens in frames, which are made out of polypropylene and then welded together to stages with different functionalities. The production processes of frames and stages are fully automated and easily scalable. Several of such stages are then sealed together to form one module, which contains all the different functionalities necessary for the saltwater desalination. In each of these frames, we have what we call a water space. Water flows through these vertical water spaces defined by the frames and is separated from what we call vapor space by either a hydrophobic membrane or a very thin PP foil. This setup is repeated through several stages of the process. The number of stages does define the thermal efficiency of the process. To start the process, we let salt water flow through the stages to be separated into the distillate and the concentrated remains of the water called brine. Next, thermal heat is applied to the hot side of the process. This heat should have a temperature between 50 and 80 degrees Celsius and can be low-grade waste heat. For example, waste heat from cooling cycles of power plants, generators, or chemical processes would be suitable. The heat necessary could also be generated in a sustainable way using thermal solar collectors or geothermal heat. On the other end of this process, we apply a cooling loop of water with a typical temperature of 20 to 40 degrees Celsius. The temperature delta between the hot side and the cold side provides the driving force for the process. In order for the distillation to start, we now have to apply vacuum to the system. The lowering of the pressure starts a process of evaporation at the first stage where the thermal heat is applied. We therefore call this stage the steam raiser. The water in this steam raiser is contained by microporous hydrophobic membrane, but the vapor being created by the vacuum now passes straight through the membrane into the steam space. Here the vapor immediately hits a foil, which has cooler salt water on its other side, forcing the steam to condense. This condensate is collected at the bottom of the stages and is the desired product of the process, pure distilled water. This continuous process of steam generation and condensation releases condensation energy at the foil, which transfers into the colder salt water, heating it up. Within a few moments, the water in the second stage is also hot enough to evaporate. Now the steam passes through the membrane into the steam space to condensate and to release its energy again. These repeated thermal events happen in each of the memsys effect stages. Because of the high thermodynamic efficiency of our stages, this recycling of energy can happen many times, and we archive a very high output of desalinated water through the multiple usage of the same energy. This thermal efficiency is measured in GOR, and we can achieve GOR 3 to 10 with the memsys system depending on its layout. At the last stage, the remaining vapor condensates by the force of the cooling water. This distillate is also collected as product in this condenser stage, which also maintains the vacuum in the process through the volume reduction of vapor to water. The whole process is now running stable and self-adjusting to varying hot and cold side temperatures, with the temperature and pressure differences between the single stages always automatically finding the optimal levels. Advantages of the process are energy efficient through multiple recycling of the energy, robust because of its thermal self-adjusting properties and smaller tendency for scaling and fouling, because it's not water that passes through the membranes but only the clean vapor. Low investment costs through the use of plastic materials. Low operating costs because of efficient use of low waste energy and very little need for pre-treatment. Sustainable since materials are recyclable. The need for chemicals in pre-treatment is low, and waste or solar energy is efficiently put to use. Wide variety of applications due to its modularity and the ability to also deal with the very highly concentrated salt solutions. Thank you for listening. We hope the information we have provided is of benefit to you. Visit us on memsys.eu.